Welcome to Sticky Note Research. This video focuses on the question, how does the coronavirus spread? COVID-19 is a predominantly airborne virus, which means you are most likely to get infected by breathing air around you which has recently been contaminated, like from a cough. Droplets from that cough are breathed into our lungs, and the viruses inside those droplets enter our lungs as well. All viruses, including the coronavirus, have two main components. The first component is its genetic material. COVID-19 uses single-stranded positive sense RNA. It serves as a type of instruction manual for making new viruses. The second component is the protein capsid. The shape, size, and composite materials that make up the capsid vary according to the virus, but the overarching function is the same. It's basically a container that holds the virus's genetic material. Viruses are not able to replicate on their own, so in order to make more of themselves, they have to take over a cell and use the resources inside it. However, our cells have a plasma membrane barrier designed to keep things like viruses out. Unfortunately, some viruses find ways to get around this protective barrier. COVID-19 uses spike proteins on its surface to attach to receptor proteins on our cell's membrane. The spike protein essentially picks the lock of the receptor protein and allows the virus to enter the cell. Once inside, it uses specific enzymes to open up the protein capsid and release its genetic instructions. Now the production of new virus particles can begin. The virus uses the cell's own ribosomes, which are like tiny little protein factories, to read the viral RNA instructions and produce proteins to make more viruses. Here we see the ribosome producing a protein called replicase. Replicase is an enzyme that works like a copy machine, making duplicates of the virus's genetic instructions. Those RNA instructions are then read by the cell's ribosomes, and more viral proteins are created. Some of those viral proteins include the spike protein mentioned earlier in this video. The other key proteins are primarily structural, helping comprise the virus's membrane and capsid. Once there's a sufficient number of viral proteins and RNA duplicates, viral assembly can begin. Each newly assembled virus needs to have its genetic instructions, spike proteins, and the structural proteins to help build its membrane and capsid. The white and green Legos here are forming what will become the viral membrane and capsid, respectively. Spike proteins attach to the capsid portion from within. The capsid then folds in on itself with the RNA inside, forming a fully assembled COVID-19 virus inside a plasma membrane. This outer membrane allows the new virus to fuse with the cell's membrane and release the virus out of the cell. This entire process then repeats itself with all the newly assembled viruses inside the cell, exponentially multiplying the number of viruses, which can go on to infect more cells in our body and more people. Thanks for watching this video. In the description below, I'll include links to more of my COVID-19 videos, as well as links to other really helpful informative resources, such as Minute Physics breakdown of why wearing masks is so effective. In the meantime, I know it's been a full year, but please keep wearing a mask, make sure you're maintaining social distance, and keep washing your hands or using hand sanitizer. It's been a year, so we're getting good at it, right? And that's it for Sticky Note Research. See you next time. Oh, here we go. Okay, ready? Now stand. Can you stand over here with me? Ready?
Right down right here.
Can you stand right here? Oh. Good. Okay, come stand here. Ready? I'm gonna go.